done that. And so much so that when the Apple iPhone 5 came out with a new map application that was flawed, it was front page stories, everywhere in the country. It was news on the nightly news shows that this application that was so much part of people's lives was flawed, and it had, like the Washington Monument was in the wrong place, things like that. Okay. The 3D representation that you see in computer games also work in computer-assisted design, medical, the molecules. You've seen all these kind of rotating, flying molecules, DNA molecules, and in architecture. These are noble, important, positive applications, and that work continues. It's a great success story. The new story, the place I want to turn attention to, is here. These are physical world representations, but this is a little mystery. So this multivariate or high-dimensional data, I said, like, 10,000 rows and 40 columns. 40 columns means 40 dimensions. I'm going to be looking at 40-dimensional data, not just your ordinary 3D or 4D or 5D, but that's what we're after, is how do we look at 40 dimensions? Maybe not all at once. We might need, 100 two-dimensional displays to get the idea of what's happening in this 40-dimensional space. But that's where we're going. We want to understand the relationships that are complex. There's temporal data. Things change over time. How do things change? Are they getting faster or slower? Are they getting bigger or smaller? Was there a certain event that triggered some change? Okay? And this is important whether you're studying patient histories or population public health data. You want to see changes. Okay? Tree structures, common thing, and this will take a look at a number of ways of showing tree structures. And finally, the really tough challenge in our current work about network visualization. How do I see the social network in this room? How do I see the social network of the 1 billion Facebook users? Or even one user. How many people have Facebook accounts? Let's try that. Oh, shyly, okay, half of you or so. And, you may have 100 or 200 friends, but how do you understand that? And, one of my students did make a visualization and very clearly grouped into his high school friends and college friends and his family and other personal friends. And so, once you begin to see the structure of the invisible relationships and you see them all at once, you can begin to make judgments and decisions about what you're doing. Okay? The fun story is that visualization become a cultural phenomenon. And I put down some of the blogs that I like Infosthetics and Flowing Data. Actually, I have the book from the Flowing Data guy just to show, and maybe I'll pass it around. But Flowing Data, it's a student at UCLA in statistics, and he's got this book out, Nathan Yao, called Visualize This, and you might take a look. It's a very nice how-to guide with lots and lots of examples. So I'll pass that around. And so that's, just great fun to see that these things have become cultural phenomena. Every morning he sends out a tweet with a link to the cool visualization of the day. And then everybody begins discussing, and there's lots of websites that deal with these kind of things. Infosthetics is another one that also has wonderful examples every day of great visualizations that reveal something about the election or the budget or whatever else is in popular attention. Now, another phenomenon, and it might be a good place for you to start because it's free and it's really good, is called Many Eyes. Many Eyes is the creation of Martin Wattenberg and Fernando Villegas when they were at IBM. And it's a free website with 20 different kinds of visualizations. Let me see if I can get there. We had this loaded up before. Where did I go with that? Sorry, I've lost it for now. And there's my Twitter. Oh yes, well I guess we're going to try to show, but within Spotfire, if you go to Spotfire's website, there's a whole demo gallery, and there's dozens and dozens of examples, and they work. So if you want to explore the data set, you can click and see these are about airline, well, scary things, but about airline accidents. The number of major ones or substantial ones, and the ones that had crashes or that the plane was demolished. These are a bit scary to look at, but you can see the relative frequency of that, and you can see whether this accident happened with experienced pilots or young pilots and so on, or inexperienced ones, and where they happened, what was the cause. Again, I'm not going to try to do this because the resolution up here is just not enough for you to see what's going on, but you can try these all on your own. That's all free. And then, you know, where were these accidents, which states had them. So if you click on a state like California, it'll tell you all the places where there were aircraft incidents, or you click, let's see, about Maryland. There's only 3. You can't read them, but Baltimore, Gaithersburg, Frederick, Annapolis, and Westminster, I guess there are airports all over there. And so it's very quick that you can jump around and see none over there, but you know which state had a lot of accidents and where those accidents occurred, incidents by region, and the number of reports of the accidents, and the minor as well as the major accidents. Okay? So that's the idea of this interaction, and I was going to go to many nets, so I'll do it just like I was showing you. Where's the slide? What's the address? Let me grab that. www.958. What a strange address, huh? www. There we go. I had it up here before, but it went away. But there are, on the website, again, we're in trouble to see too much, but you can create your own visualization, and it walks you through the steps of creating it. This is not going to be great here. And then the good thing about Many Eyes, I can do a little better here. A little better. But the sweet thing about Many Eyes is you upload your spreadsheet, and then you select the visualization, and you create a visualization, and then it gets stored on this public website. So that's good news for getting things out there. You may be working with data for which privacy is a concern, for which you don't want to expose them publicly, but you can see there's I don't know how many, about 100,000 up there posted already, and if you go to any one of mortality rates, under 5 per live births. Okay, let's take a look at that one. Come on. Are we connected and connected? But we're not getting there. Hello. Try one. There we go. All right, so you can see how this works. And so these are simple visualizations. The good news is it's really easy to get started in doing visualizations. It's free. They have 20 different visualizations. The bad news is it's not a rich and powerful tool, so you may, as your sophistication grows, may need to do more powerful things to get your work done. So the visualization types are things like scatter plots, matrix charts, network diagram, bar charts, histograms, bubble charts, track rises over time, see parts of a whole, pie charts, tree maps. How many people know about tree maps? No. All right. You will by the time we're done here. That's one of my creations, which is just very satisfying to see how well it's traveled. Analyzing text, so various versions of Wordle and other kind of things, and then maps of the world as well. So it's a great place to get started and to learn about this. It may actually produce something useful. You could produce screenshots for a presentation. They're colorful, they're really easy to get started, and that's sort of this is the place my students start. Their first homework assignment the first week in my course is do something with Many Eyes, excuse me. Okay? And, my point in this workshop here is not to promote Spotfire or Many Eyes, but to give you an overview of the topic, because you have to decide which tools become appropriate. All right. This is still the motivational part here to convince you that you can do better than spreadsheet data, that visualization really helps. And this is a famous example by Fred Anscombe, a statistician, Princeton and then Yale. And Anscombe had these 12 rows of data. There are 4 groups of data, the first, the second, third, and fourth. And I'm going to ask you, what do you see that's interesting here? Do you see something in any of these data sets that catches your eye? It's kind of tough. But I'm going to give you a moment to.
Second column in each set is different. Values
second column
values in second column in each set
is
different.
but the values in the first column
Is the same.
almost. You did make the important observation that x1, x2, x3 are the same, but no, that's not.
That's true.
That's true. Okay, so actually it's even better because you made a misinterpretation. I just want to show that even with 12 rows of data, it's pretty hard to make sense of this stuff. See anything else interesting? Catches your eye? Catches your mind?
X4.
Yeah, X4. That's pretty weird. They're all 8.0. Thank you. Except for this one. All right? So there's something strange going on. And another observation you might make is that all the X values are integer values. They're 0.0. Whereas the Y values are. Does anybody imagine what the shape of these graphs are if I plotted them? Or if I took this away, would you be able to remember any significant fraction? No.
No.
So if you're a statistically inclined person, you say, well, okay, I understand, but that's what statistics are for. Why don't I look at the means and standard deviations and correlation coefficients for these things? And if you do, you'll find, disturbingly, or maybe surprisingly, they all have the same mean for X, the same variance for X, the same mean for Y, the same variance for Y, the same correlation coefficient, and the same linear regression line. If you fit a straight line to it, they all have exactly the same. Pretty remarkable. Yeah, that was Anscombe's point that, he could make these four. Now, are these four very special? No, actually I could find 40 or 400,000 or 400 million of these that would fit these properties. And so the point is statistics, which are great, I'm a great fan of statistics, but without visualization, you just can't make sense of it. Now, get ready, pay attention, I'm just going to count down. I'm going to show you these four graphs, and in 400 milliseconds, you are going to know what these are about. Ready? 3, 2, 1. Okay? So pretty quickly you see that x1 has a kind of positive correlation, but not a perfect one. x2 is a perfect quadratic fit. Okay? What about this? What do you call that? Outlier. Okay, that's the usual term. Is it an outlier or is it an error? Or is it an anomaly? Well, we can't really tell, but when I see something like this, I have to ask you a question, what is that? And if you look up in a statistics book, what's an outlier? Is this an outlier? What is an outlier? The definition will say 3 standard deviations from the mean, assuming a normal distribution. Bell-shaped curve, normal distribution. I have never seen a normal distribution any data set I've gotten. I just don't get those, okay? They're just really all kinds of much more complicated structures, okay? In fact, if you're really into this kind of statistics stuff, the book, The Black Swan, Nassim Taleb, is a real gem because he talks about the normal distribution as the great intellectual fraud. And he just condemns all the Nobel Prizes in economics based on the assumption that there's normal distributions which aren't. So this kind of thing is what I would think is probably an error. And then over here we have this also funny kind of data pattern. Okay, so the point is these are visible, they're understandable, they're memorable. You could, if I take this away, you could probably draw these from memory. It's very powerful, even with just 12 data items. You get a huge insight payoff from this approach. And that's what I'm going to try to show. So the first demo here is a time searcher, time series data. And where are we? Here we go. This was the PhD work from Harry Hochheiser. And what we're looking at is a very simple data set, which is 223 stocks over a 13-month period. Our work was really based on genomic data, but that's a little more complicated to explain, so I like this simple demo. And you can scroll through these 223, and you can see that some go down, some go up and then go down, some jiggle around, some are fairly stable, some are unruly. You know, there's all kinds of patterns here. So how do we look at 223 stocks, or how do we look at 10,000 stocks? Okay? Well, you know the rules by now. Overview first. So let's look at all 223. Even in a small data set, it's pretty messy and hard to see anything in particular. I can go find individual ones by details on demand. Okay, so I can go, but that's not too helpful. All right, my question to you is, do you see anything interesting in this 13-month period? You do? What is it?
February.
February, right. You train your mind and your eye to look at this. You see that there's a kind of high volatility in February. And so we want to look at that, don't we? Let's look first. You know, we're not just looking, we're thinking. We're asking questions. And our first question is, what's going on in February at the high end? So we select what we call this a time box, and we look at that, and we see a very dramatic result with two insights: that every stock that went up in February went back in March, and there's one stock, Adaptive Broadband, which went up in January ahead of everybody else. So what's going on? Were those traders especially knowledgeable that they anticipated this rise? Was there something unique about the company? What's going on? And we want to know those things. And those are the kind of insights we're having. We could look at the bottom, and there's other things we could point out there. Or when we talk to our stock market friends as well as our genomics friends, we said, what question do you have? They said, show me the things that start low and finish high. And we said, okay, we can do that. And the question they had was, the things that start low and finish high, do they go consistently up, or do they go up and down? Was there a certain period? And you can see a quite erratic pattern. There's no particular way that these things went along. And you know, they said, well, what I really want to see are the stocks that start low, they go up, and then they stay up. That's really what I'm after. All right, so we could go after that kind of a pattern. And so what Harry's program, free for you to download, lets you explore the data any part of the year and go hunting for the times when you get a lot of stocks that start low, go up, and stay up for a while. Okay? And then our users came along and they said, well, really, that's cool. Well, we want to see the things that go in the opposite direction. If you know about genomics, that's really important. Any genetic pathway is going to have processes where some genes are more active, but other genes are less active. So our genetic friend said, hey, we need to see those. Our stock market friend says, yeah, we want to see those too, because sometimes there are stocks that go up, others go down. If IBM goes up, does Microsoft go down? Or if Apple goes up, does Google go down? Let's, you know, we can take a look. So Harry added this feature, we flip, okay? And we just flip back and forth to be able to see the opposite pattern. And so we became more and more aware of the need for tools that let you search for patterns. And then as we talked to our users, we came to understand this discovery of patterns was the essential feature that they were after. All right? Any questions about this? Free to download, simple to use, time searcher, you know, on our website, HCIL website, time searcher will get you there. Time searcher 2, okay, any questions about this? Yeah. We've had thousands of users, and we're very happy to see people putting this to work.